Welcome, everyone, to episode 1 of Unwinding the Spool Podcast. My name is Andrew, and I am joined by my lovely friend, Will.
Hey, everyone, I'm Will.
Yeah, so just a quick kind of intro for everybody. This is a podcast all about 3D printing, or a podcast for makers who are kind of defined as the people who really enjoy 3D printing and creating cool stuff. So in episode 0... which we recorded a few weeks ago, we talked about our backgrounds in 3D printing or additive manufacturing, how we met, what we're doing now, and kind of what our plans are for the podcast. So if you missed that episode, definitely go check that out either on the YouTube playlist or on our Anchor or Spotify site. You can catch it there, the audio version as well. So, Will, what are we going to be talking about today?
Thank you for asking, Andrew. So today we are talking about what is 3D printing. This is the perfect episode if you've barely heard of it, if you don't know a whole lot about it. This whole series of episodes here in the beginning is going to be a lot of what are the basics of 3D printing. And so today we're just going to kind of go over what it is and kind of how it works and why it's great or not so great, and kind of where you can start. So I guess to get started, Andrew, how would you define 3D printing? What would you say it is?
Well, it is kind of like 2D printing because you're using a computer-driven machine that is plotting material in a specific pattern, and in this case, it's not ink on paper; it's molten plastic or metal too. I think the best way to describe how a 3D printer works, though, and it's the common phrase that I always go back to when I'm telling someone about 3D printing who has zero to little experience or background in the technology, is most people have heard of a hot glue gun. If you've done any kind of like project or hobby or crafts, you've probably used a hot glue gun at some point. You've gone to the craft store. Well, for those people that haven't heard of a hot glue gun, you basically get these cylindrical sticks of plastic glue, and you stick it in this gun, and as the name suggests, it heats up and melts the glue, and you can kind of use it to bind different things together. It's not super strong, but it's good for, crafts and little things like that. But basically, a 3D printer is like a hot glue gun that has been attached to a computer motorized carriage, or basically crane almost. And then you have your 3D model, and maybe we can get into this in a little bit later in the episode, but you have your slicer software and it cuts the model, and then basically your computerized glue gun is extruding that glue in a layer by layer fashion. That's another kind of phrase that you always hear with 3D printing, is layer by layer, and it's because that's how a model is built, just like the name additive manufacturing suggests. That's how you're building a part in an additive fashion versus the other side of manufacturing. Some people might have heard of this. It's called subtractive manufacturing. So that's your typical milling, machining, grinding, however you want to describe that, whether it be wood, metal, acrylic, I don't know. Will, do you have anything to add to that kind of like basic overall analogy that I might have left out?
No, that's pretty good. I mean, just the way I like to think about it is if you take kind of we're going to get into the slicing and all that software in a later episode, actually. But we're working a little. But this is just talking with that. That's exactly it. Is you're taking, imagine a glue gun, or sometimes I like to imagine like those big cement pouring machines where you can kind of move it left and right and up in the kind of X and Y plane, and you can pour cement kind of in this X and Y fashion.
Sorry, my ring is like going crazy here. Apparently someone's at the front door.
Who's at the front door?
It looks like some Boy Scouts. Trying to sell some popcorn or something.
Wow.
Okay, sorry. Pardon that interruption. We have to remember to silence all our devices.
Yeah, please silence all your devices. Put your tray tables up and lift your seats into the upright fashion. So that's effectively what you're doing is with additive manufacturing. I like the way you put it, Andrew, is 3D printing, additive manufacturing, whatever you want to call it. You're taking something, you're making a layer, and then you're adding a layer on top of it.
Right.
Even no matter what type of way you're doing that, Andrew and I are going to talk about different kinds of technology throughout this podcast. Not this episode specifically, but maybe in future episodes. There are lots of ways that we create things layer by layer, but the very basic idea is just we are taking a layer of an object we want, building it out, then putting another layer of the object on top of it.
Yeah, exactly.
And that's about it.
Yeah, and I guess something that I kind of just thought of now is like we use the hot glue gun analogy. That's a little bit more common example that most people know what a hot glue gun is, but they actually have 3D printing pens.
Yeah, they do.
Which is a more rudimentary form of the technology where you take the computer-driven part of it. That's another thing that I think a lot of people mistake when and I do this sometimes too. The acronym CNC. A lot of people coin that or describe that to, what is really conventional milling or machining, whereas technically a 3D printer is a CNC machine. Which, right. For those that don't know, CNC is computer numerical control. That just basically means that whatever it is that you're doing, whether you're subtractive manufacturing, additive, is driven by motors, stepper motors, a computer that's driven by code and a special from a slicer software. And with those 3D printing pens, you basically take the CNC part out of it and you're just extruding the filament and then doing it however you want. I don't know really what the novelty or where those 3D printing pens really apply, if there's any kind of use for those, but I think it's more of like an artsy craftsy thing.
It's way more of a crafty thing. I think it's very cool because it allows some pretty cool forms of art and artwork.
Yeah.
It's definitely less on the industrial side. Way less. Like I don't think I've ever seen ever an application of a 3D printing pen. It's great for like education purposes.
Sure.
Yeah. I actually, you bring up a good point. I may have some in my classroom just for kids to play with and break, but who cares? But I think that that's a good point. Is this idea that a 3D printer is a scene, like all of these. That brings up another good topic about what is 3D printing, which is similar to everything. It's a computer controlled simple system that's run by a code called GCode. Is incredibly basic, and it's been used since the early 90s, even like the mid 80s. Yep. It is just it's a set of coordinates and an action, and that's all it is.
Right. It was kind of funny. Sorry, I mean to cut you off there.
Very good.
In one of my first summer jobs while I was in college, I was, not to get too far off on a tangent, I was operating a CNC machine that was cutting musical instrument reeds, like they were synthetic musical instrument reeds.
I forgot about that job.
Yeah.
Oh my gosh.
And so that's when I really got my first, because this was just before I kind of really started to get involved with the 3D printing project with you at school. And so that was my first kind of experience hands-on with the CNC machine. And this thing was a custom-built CNC out of the 90s, specific for this application. And it was still running Windows 95 or Windows Millennium.
Oh, man.
Yeah, and it was like one of those things where if you don't start up the computer in the exact sequence, like everything just goes haywire, So.
Oh, no.
So, it's kind of cool to see where this CNC technology has gone. I mean, we've gone from very basic rudimentary computer-driven machines, whether it be for additive or subtractive or, we're just talking, manufacturing, but there's a lot of other CNC-driven processes for different industries as well, which we could get into that in another episode. But, now we've got, crazy 3D printers that use all these crazy technology. And, one thing at my work that we just got in was these DMG Mori 5-axis like machining centers. And just to think that's where we're at now is these like state of the art, where you can machine up some really crazy parts without having to refixture them a million times,
That's crazy.
Yeah. So anyways, not to get too far off on a tangent, but moral of the story is, I think, summing up kind of our first point is that a 3D printer is a CNC machine, computer numerical controlled. It's driven by G-code, as Will said, and it's driven by stepper motors and a computer, basically. And the easiest way to describe how a 3D printer works is just attaching a hot glue gun to a motorized computer-driven head or carriage that follows a specific pattern that is mapped out by the G-code, and then you build your part in a layer-by-layer fashion.
Just to summarize the summary, because I feel like that's a good summation. I like that. I just wanted to add, which is like, even beyond just to simplify even that carriage mentality, is like, imagine it's like a crane hooked up to a computer, hooked up to a glue gun, and it's just going all over the place and making things layer by layer.
Yep, that's great. So I think, that was kind of the goal, was to start episode 1 with this discussion point to really kind of help bring in the people who are like literally have no idea what a 3D, like, is a 3D printer like a regular inkjet printer, but they just, but no, it's really not. It doesn't share too many features with a standard 2D inkjet printer, I guess.
Very, very little. But let's just to move the show on. So Andrew, why do you consider 3D printing great? What are the things you love about 3D printing?
Right. It definitely has many great areas. The first, and I'd say, and at least in my opinion, the biggest positive or pro of 3D printing is your ability to rapidly prototype. So that's a common phrase that you'll hear in the additive manufacturing world, is rapid prototyping. And that basically means, for an engineer like you or me or whoever else, if you're designing a custom part or a new part or a replacement part, and you're not, sometimes, you can do all the calculations, you can do all the stuff in CAD that you want. And when you have the physical part in the real world, it doesn't always fit sometimes, or you feel it in your hands and it needs adjustments. Well, that's where really 3D printing really shines in this particular area, is that it allows you a much quicker turnaround time. That's another buzzword that you'll hear in the industry, of being able to design and then get a physical part in your hands, versus if you were to do that by conventional milling or machining, it would take significantly longer and be considerably more expensive, because you're obviously doing it out of metal, versus like a quick prototype part can be made from, cheap PLA plastic, or non-expensive material. I think that there's many, areas why it's so great, but I think that's the biggest one. Do you have anything else to add?
No, yeah. So just to come from a different angle, for me, I think the biggest, most enjoyable part of 3D printing for me is being able to take an idea from your head to the page to a modeled object to a physical object pretty quickly. So from a creative standpoint, from an industrial standpoint, Andrew, I love your point about it's really good turnaround times. I mean, a great example, not to get too far off my own point, but a great example of that was when we were working on the cart, and we would send a part to go get machined at that shop in the mechanical engineering department, and it would take 2 weeks, and we'd have to go get the material and bring it to them, and they would take 2 weeks, and then we'd get it back. We very much appreciate the shop at the mechanical engineering. They're the only reason we had metal parts. But for fitting and fitments and stuff, we had 3D printing, so we were able to churn out 2, 3, 4 different versions of a fitment within a matter of a day. And we could just be, boom, this fit. Nope, that didn't fit. Right. And then the great thing is we could send the actual prototype with the material and be like, this plastic prototype, we need it made out of this metal.
Right.
Go for it.
Yeah. No, and that kind of also plays into another con, piggybacking off of that, is like when you're designing something and 2D like drawings on, when you make SolidWorks drawings or whatever CAD program you use are great. You can have isometric views, and you got your basic, 3 front, side, top views, to kind of try and give whoever it is, the person that's making it or who you're working with, an idea of what this part is and what its shape is. Sometimes, though, with really abstract parts that are complicated in design, or there's minute features that are hard to visualize on a 2D drawing, it's great to have a quick demo piece that's 3D printed to show, whoever it is, the machinist, your project manager, like, hey, this is the hole, or this is the chamfer that we need to change because of this, So it's a great visualization tool also, whether it be for, work or for education, right? You can use it in a classroom setting, or, in college when you're trying to demo, how parts fit together, thread engagement, stuff like that.
Yeah, and I think it's such a great way to, especially if you're me and you have a lot of anxiety around part fitment.
Yes.
Where I've just got all this like, oh man, I don't want to tell the guy to do this and then it not work because that's time and money wasted.
Yeah,
I love being able to like make a 3D printed, quick, cheap piece out of plastic and just like, boop.
Yep.
Check it out.
No, it's definitely takes a lot of guesswork out of. I mean, it kind of assists your guesswork, I guess, to some degree, versus spending all that time and money and you machine a part out of billet aluminum or whatever, and you're like, well, that doesn't fit, so we got to go back to the drawing board.
Exactly. Yeah, and I mean, also going back to kind of from the creative side, I think what's great is you can take like an idea, like man. Well, I mean, one of the things that Aldrin and I, my business partner, I mean, you, Andrew, have also worked on is like printing out objects from fantasy games or all kinds of things. So, like, for example, actually right here on my dad's desk, I'm at my parents' house, actually. But this is a little ocarina from the Ocarina of Time, which is a Zelda game. Oh. And so, like, it's a working ocarina.
That's pretty cool. For those that are listening, it's like a little musical instrument, right? Basically.
Yeah, it's like a little flute, like a pan. Yeah. And so, what's great, we'll have photos of that up on something at some point. We'll have to reinsert that here.
But we'll have an Unwinding the Spool website where we can have our collection of images, or at some point.
Yeah, some of the visuals and things like that. But so the beauty is being able to take things that exist in our imaginations and exist in kind of the world of our kind of far-reaching dreams and things like that, and you can make them a reality very quickly. And you can kind of understand, you can also understand the difficulties of making them real quickly. So that way you kind of understand, hey, if I want to do this art project, if I want to make this sculpture, if you 3D print it and it's got parts where it fails, you can go, okay, well, that would have been hard to do with conventionally making it as well.
Right.
And also what it allows you to do is if you have this idea for, I don't know, if you want to make like a brand new product and you're really excited about it, and like, let's say you've got like a great idea for a door handle or something, I don't know. Let's just say that. You got a great idea for a door handle. You've revolutionized how we open a door. And you're just like, oh man, this thing's going to blow the socks off everybody. And then you go and you 3D print it and you go, this thing doesn't work at all. Yeah. This is garbage. Or you can go, like, man, this is going to change the world. But either way, you get instant feedback. It's that feedback and I think that's kind of what we're getting back to as well here with the industrial, the creative, all these, the educational side. Mm-hmm. I'm really excited to incorporate it in my classroom this year with robots, where they're going to, kids are going to ask for certain parts to be printed, and I'll be able to 3D print them, and then they'll be like, wait, that didn't fit. And I'll be like, well, don't worry, hey, that's okay.
Yeah, that's part of the process. Yeah. Yeah. No, it's a very empowering tool, and I think it really brings down the barrier to entry for a lot of different projects and businesses to convey their idea in a new product. And like you said, on the flip side of like, if you created this door handle and you're like, well, that doesn't work. But at the same time, if you had the access to a 3D printer and you're able to print a prototype, and let's say you go to a venture capitalist meeting or a funding meeting or Shark Tank, I don't know, and you're trying to like pitch them, it's way easier, in my opinion, to convince someone when you have a part in your hands that, is tangible, so that people can see it. And it's a very satisfying experience. And aside from just the functional, feasible side of it, it's a satisfying experience too with 3D printing, being able to go from a digital design on a screen, and within a matter of hours or a day, you can have this part in your hands. It's a very empowering feeling,
Yeah, and that creating access too is we'll talk more about the support softwares and the other pieces of 3D printing later, but the modeling, the slicing, there's free versions of all of this online that you don't even have to download the software. You can actually just use it in your browser, and that makes it such a powerful tool where just about anyone can access the necessary things to get to a 3D print. And then not to mention, with the world of public makerspaces and library makerspaces, it's also probably feasible to find a 3D printer within your area. To use.
Yeah.
And so,
definitely.
yeah. I mean, you can
I think that's a later point, and we can talk about of like where to find your first 3D printer to use if you don't have the means to purchase one, which most people, when they're first getting into it, it's hard to digest dropping hundreds of dollars on something. You're like, do I even know if I like this or not?
Absolutely. I mean, you have your own personal story, and we can get to that for sure in a second.
Yeah.
I guess before we dive into that, do you want to talk about the not so great? What do you not like about 3D printing?
Yeah, no, it's definitely a fair point that we need to talk about. Also, it is not a silver bullet technology, unfortunately. There's nothing like that in this world. I'd say the two biggest drawbacks when it comes to 3D printing or additive manufacturing is the materials. When you're printing, most of the time when you're 3D printing, you're printing with polymers and plastics, right? Where, if you need a part that needs to be really strong or be, pretty resistant to heat sometimes, it can be tricky. It's not impossible. There's been huge breakthroughs in material technology and innovation over I'd say the past 10 years even, with polymers in 3D printing. And then of course now there is metal 3D printing too, but that's the upper echelon of additive manufacturing, so definitely not a lot of people have access to that. But so the materials is one. However, that'll be a whole nother episode. It's just talk about materials with 3D printing and all the awesome materials that we have access to, because that's a lot of juicy content right there that we could get into quite a rabbit hole. But they've come a long way. There's still a little bit of a drawback with certain parts. Like I've just been kind of doing some random material testing on my own and seeing how parts hold up to heat and weather and UV, and stuff like that. And then I'd say the other big drawback from my point of view is just the time with how long it takes sometimes to make a part. And there's a great visual that when we get our little database going with pictures and visuals and whatnot, there's a great visual that I found online at some point that shows you the return on investment versus I think it was time to make the part compared to cost of the part, and also or initial cost as well. So that's where like under 10 parts, you're really in good shape for doing 3D printing, because you don't have to make mold tools, you don't have to set up for expensive milling machines. But then the minute you try and produce hundreds, thousands of parts, it's a diminishing return as far as making it worth it in 3D printing. That's where like injection molding would take off and be more of an advantage. So, it can definitely take a long time to print parts. I'd say like certain larger parts, if you want them to be stronger, have denser infill, like you're talking at least a few days sometimes. And, if you're trying to make a bunch of parts, your printer can get backed up and it just takes a while. But so yeah, I'd say those two things are, from my point of view, the largest drawbacks. But do you have anything to add or that?
I would say, talking about access, it's like, we'll talk about it in a minute. Like there is a lot of potential access, but I wouldn't say it's at all universal or at all everywhere. And the issue is because we've now had a decade or so of different technologies, of different companies making different kinds of styles of printers.
Sure.
We don't have like a universal go-to. Mm-hmm. And so I would say, there is a huge, there's a tendency for people to blame 3D printing as a whole for the reason it didn't work, when it may just be that 3D printer or how that person takes care of that 3D printer, or where that 3D printer is. I mean, we'll get into this about how it can be sometimes. I mean, if you're printing in Minnesota versus Southern California, you're going to have very different experiences, and you're going to have very different climate controls.
Sure.
I mean, I don't know, Andrew and I don't even put a box around mine. We don't have the fluctuations of environment that people in different climates would. And so I would say that the issue is, there's an expectation that it performs as well no matter what, like a document printer. Like you should be able to go out and grab one and it should perform the way you want it to.
Right.
And it just doesn't. It's just not here. And also I think for my second kind of like gripe about it is the amount of money you can spend on a printer and still have to work on it. I've worked with printers that cost $700 and printers that cost, upwards of $10,000, and both of them have all anywhere in that spectrum. I've had to tinker on it. I've had to open it up. It hasn't worked perfectly. And I would say that's still one of those things where, like, if you spend, don't get me wrong, you spend $125,000 on HP's new, like, part making system. Yeah, it's going to work. They also have an engineer come out and set it up. So it's not, like,
they have expensive service contracts that you have to upkeep the maintenance, and, there's many things that come with that.
But, like, for you and I, both of our printers, and all the printers at my school, I mean, they some of them I fixed because they just needed fixing, even though they were like the school versions that were supposed to be kind of bulletproof and like they still need to be fixed.
Yep.
So I think that those are the two things. The access needs to be better, and then the
I guess the clarity.
The clarity on what needs to be done needs to be more consistent. We need to understand that this is still very much like a...
So there's a big learning curve that a lot of people aren't aware of. Yeah. Yeah, no, I think both of those points are extremely valid, especially the one about the learning curve. Like, you nailed that on the head, because I'm a part of several different 3D printing, like, forums and groups, like on Facebook and whatnot. And I can't tell you how many people ask the same question. There's obviously common problems that happen with, people who are getting into 3D printing as beginners. But, like you said, exactly, it's like a lot of people expect these things that you pull them out of the box. Whether you spend $400 or $4,000 on a printer, you expect them to pull out of the box and print right away. And to some level, you can get lucky and, you'll have a pretty good experience. But at the same time, you may be able to print a part and have it, the part finish successfully, but the print quality might not be great. Like, you might get a lot of blobs and stringing, and that's a troubleshooting episode that every time we have a new conversation here, I feel like we keep unraveling content for more episodes, which is great because we have so much to talk about.
No, we got a lot to talk about. Absolutely.
Yeah, but it's a big misconception that, like, you can get these things, plug them in, load up a file, and boom, you're good to go. Like, there's a lot of learning that has to come with it, and being a good troubleshooter, and doing cause and effect analysis of, like, okay, the effect was my print was, very stringy. Well, the cause of that might be, retraction settings. Like, you have to know how to tune your printer based on the results and whatnot.
Yeah, and I mean, just to add on to that, the analogy that I've heard and used a lot is, I think people assume we're at modern day, like, personal computing products in that same way. Like they assume that 3D printers are in the same vein as, like, an Apple computer that's just ready to go out of the box. Whereas really 3D printers are still kind of in, like, the Apple I wooden, like, computer that you built yourself and, like, had to tinker with and bought a kit. Like, we're still really in 3D printing. We're there. We're very much, like, maybe we're a little beyond it, but we are still early on in the evolution of it as a technology that can just come out of the box. And that's partially not even on the consumer. That's on the advertising of the industry. I mean, the industry loves to tout that they've got this machine that just works day in, day out, right out of the box. But I mean, even Ultimakers, even some of the industry-leading printers still need work.
Oh yeah, we've got an Ultimaker 3 at work in my office, and I tell you, that thing has almost given us 10 times more problems than our the Creality printers that are a fourth of the cost.
There you go.
So, there is some level of, like, cost will give you a better quality printer, more features, and it might be a little less prone to breaking, but there's still, even with the expensive guys, like you said, Will, like, you're going to run into problems that you got to know how to troubleshoot or know the right questions to ask and research.
Absolutely.
So. Yeah. So 3D printing is awesome. Definitely has its drawbacks, just like with anything. But I think they're easily able to be overcome with the right amount of research and education, and just how to apply the technology in the correct areas and not, that's the other thing too, that I think sometimes happens is people 3D print things that don't need to be 3D printed.
Right. Exactly.
If you're trying to 3D print like a bolt or a nut, like go to the Home Depot and buy one,
So much cheaper.
Right. The idea with 3D printing is to make stuff that you can't get off the shelf commonly or that costs a lot to machine, that
absolutely
would be more difficult to get. So, so it's got pros and cons, just like everything. So let's see. So our next talking point is kind of like what's next for the technology industry. So how could we approach this question without kind of getting too far down a rabbit hole? Because this, episode's obviously intended for beginners, so we don't want to overwhelm them. But
yeah, so for the beginners, I'd say where we're at, you've probably seen you can print plastic parts, you can print metal parts, you can print. Where's the? I think one of the interesting. You know what? I'm gonna just say I'll say for my answer, I'm gonna say one of the really weird, interesting ones that where it's going is 3D printing food. That's one of the weird ones. So
okay.
I don't know if you've seen this, but it's this like they take this mushroom protein slurry and they 3D print a steak. Like it's got this tube and it's just kind of pneumatically shoving this liquid, and it does it layer by layer, just like a normal 3D printer, and then you can cook it like a steak. And it bleeds like a steak. And it looks cool.
I did not know that they were doing that. I've seen people like 3D print chocolate, like they heat up chocolate and extrude that too. But I did not know they were doing that with like mushroom steaks.
Yeah. No, so that's one of the, where's the technology going? I have no idea what it's going to be, what 3D printing and food is going to really end up doing.
Yeah.
Where it's going, but it is going there.
Yeah. No, it'd be interesting to see like if there's a whole restaurant at some point in the future where it's like, your whole meal is 3D printed. I don't know how that'd work.
We'll have a guest star. My friend Amanda is a food scientist. We'll have her guest star on the podcast. And
okay.
We'll see what we can get in 3D printing in the world of food.
Maybe, you know what? Maybe where that might apply really well is like remote areas, places that don't have access, like shipping, like full-on crates of produce is not feasible. So they ship these little, almost like MREs. Kind of,
It's a different version of an MRE. Yeah, exactly.
Right. Yeah, you just ship this little packet of goo and then it extrudes it and cooks it.
It's perfect.
Perfect. But no, I think another area where 3D printing is definitely going, polymer technology is always growing. Recycling, obviously, Will has got great background in that. We'll talk about that in another episode. But just polymer technology in general, like now we're having like carbon fiber reinforced polymers being able to be printed, just really high temp materials like PEEK and Ultem, so really high grade polymers are now able to be printed versus probably 15 years ago, that was the upper echelon. Now it's kind of come down a little bit.
Yeah.
The ability to have access to that. And I think the other area, I did a little bit of research on while I was in grad school, because I did a few medical device focused classes, was they were, kind of 3D printing organs. That was kind of a few articles that were posted and written about. Yeah, I think it was University of Michigan, if I'm not mistaken, because, without getting into another rabbit hole, when you get an organ transplant, right, you have to take anti-rejection medication so that the organ isn't rejected by your body. So I think what they were doing was they were 3D printing like organs with just the basic tissue or cells without any DNA in it. And then they were able to print like the scaffolding for it and then inject your own DNA in the organ. And then it's like a 3D printed organ. I think they tried it with like a pig heart or something like that, but that's another upper echelon of 3D printing, but that's where it's going. It can be used in the medical industry, whether it be for organs or medical devices. Being able to print metal and like titanium is a great area for, I think a company local here in San Diego just passed through a few certifications, like a metal 3D printed like joint replacement or something like that. So that's pretty cool. Yeah.
There you go. That's pretty cool.
Yeah. And then, kind of going off that with metal 3D printing, also like aerospace, I work in the aerospace industry for my full-time job. OEMs like Boeing, Lockheed, Northrop Grumman, they're starting to really use metal additive to make parts for the next generation of aircraft or, whatever it might be. And it's really cool to see that because it allows companies to make a lot more revolutionary designs that aren't possible through conventional like milling.
Yeah, there you go. There you go.
Yeah, so a lot of different fields.
Yeah.
That 3D printing additive is going towards, and it's really exciting to see that. So we'll kind of, I think the plan, we kind of already talked about this, is, in some later episodes, we'll dive a little deeper into like the latest cutting edge areas of additive, whether it be maybe we do one on the medical field and medical industry, we do one on aerospace, just materials in general, stuff like that.
And as we get kind of deeper into it, we'll also kind of do some news updates and kind of keep everybody, try to make this a place to keep everyone updated on what's going on that's new.
Yeah.
So, yeah.
Yeah, because I know recently... sorry. I was going to say recently Stratasys launched a bunch of new products and printers, so that'd be kind of cool. Like maybe like a 5-minute segment in the future, we can talk about like some of the latest news, and stuff like that.
Absolutely, yeah. Cool. So moving on, because I know we're we gotta keep going on this timeline.
Yeah, I know. We like to talk a lot, which is why it's awesome. But
which is why we got to do this podcast, exactly. So I think for now we can I think we can wait on buying your first 3D printer until another episode. Maybe we focus on where to find 3D printers to use. Where can you find one to use so you don't have to go buy one yourself?
Yeah,
so what are some? I'll think of some, but what are some? I can think of some. But what are some sources you can think of that you kind of can go try them out?
Sure. Yeah, no, it's a great thing to talk about because, like we said, if you're just getting into this, you probably right off the bat don't want to drop hundreds of dollars on a printer. So if you can kind of just get your feet wet by trying someone else's out that you have access to, is a great way to get started. And one big one, I think, local libraries. I'm not sure. It depends, obviously, city to city. Libraries have 3D printers, and then, community colleges, community colleges will have them. And so what were the areas you were thinking, Will?
Oh, yeah, no, absolutely. I was thinking if you're at school, really check with your school, too. If you're in, even like high school or middle school, they might have them, or they might know where to find them within the district you're in. If you're at university, or even go to your local university, check in with your local community college. That's a great space. Educational spaces have a lot of them usually. Libraries tend to have them if you've got access to them. There's what else? Sometimes there are actual like maker spaces. If you look up maker spaces around you, if you've ever heard of the maker movement, if you haven't, just look up make.com. Great spot to start and look for maker spaces. I know we've done with my company, Closing Plastics, we've done a lot of work with the Los Angeles Public Library System. Right. But we've also done work, all kinds of work with other school districts. And we've also, I'm trying to think of other places I've seen it. There's also online services where you can send a part to be made and it'll be shipped to you. So maybe if you're in a more rural area and you don't quite have access to these things, there is a way where you could take a part. If you were like, man, I want to see what this looks like 3D printed, maybe I want to try this out, then you could send it away. It costs a little more. It's a little more of a cost up front, but I think some of them you can get done as cheap as $20 and you can get a little part made and test it out and see if you like it. See if you think that 3D printed product is worth using.
Right. Yeah, that's a great way if you already have ideas for stuff you want to make and you just want to see what it looks like. That's an awesome way. 3D printing services. With that, you don't get the hands-on feel, I don't think, as much of being able to work with the printer. But, if you're, like you said, in a remote location or something, it's a little more difficult to find something locally. That's another great alternative with the age of the internet that we're in. You can just send a file over the internet and have it mailed to you as a physical part. So, yeah,
it's pretty great.
Yeah. So no, there's a lot of great resources. We'll probably save this for another episode. We're going to talk about buying your first 3D printer. There's a lot of good entry-level printers that if you feel comfortable and you have some money stowed aside for purchasing one, you can definitely do that. And then maybe what we'll do in that episode too is also kind of talk about when you get your printer, what should you expect? What are some
absolutely
some basic tuning and setup of your printer that you should know how to do so that you're set up for the best chance of success possible with your first few
commenting now for us to make this its own episode.
Okay. Yeah, I think maybe we can stuff this in. We can stuff that in as episode 2, and then we can push our original episode 2 back to 3 and so on, because I think
absolutely
buying your first printer will piggyback off of this episode.
Absolutely, yeah.
So, cool. Alrighty. Well, I think we're about, at our time here. And, I think that was a lot of good content to talk about for episode 1. If you're a beginning 3D printer or maker, I hope you learned something from this podcast. And, of course, if you guys have any questions for us, please feel free to email us or leave a comment on the YouTube video. Our email is unwindingthespool@gmail.com. So I think in the next episode, like we already said, we're going to talk about buying your first 3D printer, things to look out for, setting it up, tuning it for your best chance of success. And we'll go from there. Does that sound good, Will?
Sounds great to me, man. I hope everyone enjoyed this, and I hope we didn't go off on too many tangents, but we try to keep it all at least related.
I know. It's hard to not go on tangents when you're talking with one of your best friends, just about stuff you like doing.
True.
But we'll reel it in, and I think it still makes for a lot of great content, and I'm excited to see where we keep going with this.
Yeah, I am too. So, thank you, everybody.
Yep, thank you all so much for either watching or listening. Make sure you guys stay tuned for episode number 2 coming out shortly here. And in the meantime, hope you guys are all doing well. Stay safe and stay healthy. And we'll see you guys in the next one.